Okay, here we go for review day 2, which was on rational functions and equality equations and inequalities and that sort of thing. Topics there: solving equations and inequalities, graphing, and that's the example we'll actually see is a graphing example, and applications, and I think we did rate of change in there as well. Word of warning here: these videos aren't complete as far as the topics. What I do is I sort of polish off what I think is a typical good example that will cover several of the topics, but certainly not the complete list. If there's something you need to see, don't be afraid to go back to the earlier videos and have a look. Um, okay, so we want to graph this rational function, and hopefully you've got an idea of a method that you go, like steps to go through to graph this, things you're going to look for, intercepts, asymptotes, domain restrictions, that sort of thing. And those, whatever those steps that you have, and I want you to make up your own, right? Asymptotes, this is behavior, all these things, that this recipe that you have made for yourself, uh, that's okay to put on your formula sheet. So, you should have rational functions, and then these are the things you're going to do, and a recipe for yourself. I'm not even going to write down mine. I'm just going to go through and do this example, and hopefully we'll get everything we need to. So what do I do? Well, I do a little bit of work, add to the graph. Do a little bit of work, add to the graph. Do a little bit of work, add to the graph. So first thing I see, a vertical asymptote on the bottom is when x equals 4, right? So that's also a domain restriction. So the domain is x cannot be equal to 4, right? What the range is, we don't really care, but that's the domain. And I'm going to actually start by just, I do a little bit of work. I'm going to put it on the graph. Do a little bit of work, put it on the graph. So where's 4? 4 is here. Dot, 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 dot. Vertical asymptote. Now what about the horizontal asymptote? Well, remember that this is the analysis about which polynomial, the top or the bottom, dominates, the degree, right? So the degree on top is 1 more, right, than the bottom. What's the conclusion? Well, when the top is bigger than the bottom, we say that there is no horizontal asymptote, right? When they're the same, if this was a squared, we'd just divide the leading coefficients and then we'd get that line. Or if the bottom is bigger, then it's just y equals 0. But in this case, it's actually an oblique asymptote, right? So it's an oblique asymptote. And remember, how do we get the equation of the oblique asymptote? As we do long division. So here's another example of long division. Putting in a placeholder there. And remember, this one won't go evenly, right? And the remainder doesn't really matter, but we know that this isn't going to go evenly. So I subtract and then bring down the 0 and -6 here, plus 24, subtract is -24. And so there's my oblique asymptote, y equals -3x minus 6, which is pretty nasty. So I'm going to change the scale here. I hope you don't mind. I'm going to have, where this is 4, and I'm put that scale on there. That's x equals 4. I'm going to put the scale down to go down by 3s. So this is going to be 3 and 6. That way my oblique asymptote will start at -6 here, right? Or sorry, -6 is right there, rather. And then next point would be down 3, right 1, down 3, right 1, down 3, right 1, and I fix my scale up so I can see that, right? There's the slope of the oblique asymptote, and so it's going to look something like this. Pretty nasty. All right, well, remember, once we get the asymptotes in, then it's pretty easy to see the graph's either going to be in this piece or this piece, this piece or this piece, and the rest of the analysis is going to help us out with that. So what's the rest of the analysis? Well, maybe the x and y intercepts. So the x-intercept is when y is 0, right? And then when y is 0, I'm solving that rational equation. See, this is why this is a good example. Graph is a good example because I'm also going to get a chance to solve a rational equation for you. Remember, as long as x is not equal to 4, I can cross multiply. And I know it's not equal to 4 because the function's not defined there. So I'm going to get 0 times x minus 4 is 0. And then now I've got a little quadratic equation to solve. X equals 0 and x equals 2. So I've got 2 intercepts. X equals 0. X equals 2. Right? And actually, for the most part of the graph, I could finish it now because I know it's got to get close to these axes, or these asymptotes rather. It's not going to shoot off down this way, because then what would this one do over here? This is going to go like this, isn't it? Get close to this axis, or this asymptote rather. Sort of go through here and then back up this way. What's going to happen on this side? Well, it's going to be down this way. How do I know that? Well, if it's going to get close to the two asymptotes, if it was going to go this way, it has to get close to this one. There's no 0 here, right? So there's no way it can be this green thing that I just did and made a mess of my graph. It's got to be the blue one that I did. And that's almost it, but I'm actually going to go through the little calculation to check. We can check the behavior near the asymptotes, right? Near x equals 4. And that's kind of a fun calculation to check. So as x gets close to 4 from the left, we think of f at x, and I'm going to use the factored version here because the factored version I can see where it's positive and negative better. What was the factored version? Minus 2 here, like this, and this is over x minus 4. So this is kind of the logic technique, and remember, if you wanted to use your calculator, you could put in, x is 3.99 and jam it into that awful formula and see how whether it's going to positive infinity or negative infinity. But this is what we think of, right? X is close to 4, but a little bit on the left, so this is around 4. So that means this factor here is negative, right? It's around negative 12. 4 minus 2 is positive. And then on the bottom, if this value is just a little bit less than 4, the whole bottom is a little bit negative, a teeny negative. So now on the top I have a negative, on the bottom I have a teeny negative. This is going to be a huge positive, right? Huge positive, and that's what we assumed beforehand. Okay, one more calculation that's just like that. X goes to 4 from the right. I got my same function, factored version. This is still close to negative 12, still a negative. This is still close to 2, still positive. But this is a little bit bigger than 4. So that means this thing is a little bit more than 4, a little bit more than 0. So that's a teeny positive. A negative divided by a teeny positive is a huge negative. And so then I can say y goes to negative infinity. Up here I could say y goes to positive infinity. And of course, you could use your calculator to help check that. Was there anything else that I missed? Oh, the y-intercept, notice that we got unlucky there. It's nice to have um, an easy extra piece of the puzzle, which is the y-intercept, but when I put in x is 0, I got y is 0. It was a copy of one of our x-intercepts, so that was a bit of a fail. I think that's it, though, folks. Again, this video not totally thorough as far as seeing all these questions. You should be doing your Unit 2 test again and then looking for stuff in the textbook to fill in for extra questions. Okay? All right, that's all I have to say about that.